Welcome to my video again. In this video, we're going to be looking at titration, one of the most important topic in the one exam. Uh, we have one question here we're going to answer. See the table below shows the Boyer reading obtained 125.000 CMQ of the solution of Echo H containing 6.5 gram per DMQ of a solution was titrated with a 0.06 mole per DMQ solution of sulfuric acid. So we have this value, we know what this value that was giving us, and we're given this chart to fill in this, we're going to fill in the blank spaces here. And so we have this question here. There's a question here we're going to answer. And we're saying this, the reaction here represents the titration above that we talk about. And here, this reaction is an example of a neutralization reaction. We have a base going against an acid. This echo H becomes the base, and this sulfuric acid is an acid. So this egg, we're going to find this egg value at the end of this value. So as we move on, we'll be reading the question. The first question says, copy and complete the table above. We're going to copy and complete the table we saw. So this is the table, this is the table we saw, and this is the complete table. So how you going to complete this table? You're going to minus this value from this, meaning you're going to minus final from the volume to get initial. Initial is equal to final. You're going to minus the initial. Initial will be equals to final minus volume to get the initial reading. You're going to minus the final from the initial to get the volume of A. So for volume A, to get volume A will be equals to final minus initial to get this value in the red. So you want to add these two values, initial plus the volume, we're going to get the final value, which is 25.55. So final will be equals to FA plus IA normally. So if we do this, it means you have copy and complete the table. The next thing you're going to move to find the average, to calculate the average take. The average take, in other words, also known as the volume of acid. So in here, we're going to say average take will be equal to 24.20 cm plus 24.20 cm divided by 2. How did we get this number? We know this number here, we're always going to take the volume of acid. We have three different values. This value we're going to look between them to find which one of them are consistent and inconsistent. We have 24.60, got very much margin here. So in this case, we're not going to take 24.60, we're going to take 24.20 and 24.20 because they are consistent. We have kind of consistent value between them. So in this case, we're going to take these two numbers and divide by 2. So 24.20 plus 24.20, we're going to divide by 2 like we see here. So if you divide by 2, you're going to get 24.25 cm3. And so therefore, your volume of acid becomes 24.25 cm3. So we're also always going to be using this number. In the titration value, we're going to use this number as the volume acid use. So moving forward, see here represent they are asking you in the next question here to calculate the constitution of the base, which is equal H mole per DMQ. So C here represent the concentration. We're given the concentration of the acid, which is 0.006 mole per DMQ earlier, and we are asking now to find the concentration of the base, which is question mark here. Volume of acid was given. We calculate, which is our average temperature before 24.25 cm3, like I said to you, and the volume of the base is 24.00 cm3. This number was given us from our previous problem, and so the NA or the NA of this NA and ND is the mole value from the reaction, the neutralization reaction given us. And so we're going to use a titration formula. We're going to cross multiply times in CAVA times this and AVB times this. We're going to get CAVA equals to CAVB and A. So if we do the mathematical cross multiply, CB going to be equals to this whole entire value. So we do that, it means totally CB going to be equals to CAVA and ANB divided by CB times NA. If we do this, CB going to be equals to the real value here. Ca concentration of the acid value is 0.06 mole per DMQ, and also the Va value is 24.25 cm3, which is the volume of the acid. The Nb, the mole of the base, is 2. So the volume of the base is 25.00 cm3, and the mole of the acid is this one. So we're going to times everything up here. and we're going to get 2.91, and CMQ and CMQ going to cancel like you see here, and so we're going to count 25.1 and we're going to get 25. So if we divide them, we get 0.1164 mole per DMQ. This becomes the concentration of the base. The next thing we move to the molar mass of the derivative. We use molar concentration, mass concentration over molar mass. So we are finding molar mass. So we're going to cross multiply. Because multiply, do the mathematical time this by this, and this time one, we're going to get molar mass equals to mass concentration or molar mass of the concentration. So in this case, molar concentration will be equal to the molar concentration, which is 0.164 mole per DMT that we got. So, and then we're going to get mass concentration or molar concentration. So we got our mass concentration in this case is 6.5 gram per DMQ, and then our molar concentration here is 0.1164 mole per DMQ. So DMQ cancel DMQ here, and so we divide them, we're going to get 56 gram per mole. This becomes our molar mass of the base X. So the next thing we're going to do now is we're going to find we're going to find the value of X, find the what is element S, or the we also going to find we want to know what is element S. So before knowing them, we want to know the value of it, find the value of X before knowing this element. So what we're going to do is that in here you see what so element X is, so we're going to go over there that the molar mass of the base is equal to the sum of the masses of the element. Therefore, so in this case, X is, we're going to say X plus O here plus H here equals to 56. So in this case, X here plus what is the molar mass of oxygen? Molar mass of oxygen is 16, molar mass of hydrogen is 1 equals to 56. So X 16 plus 1, we're going to get 17. So what we're going to do, we're going to rewrite everything. If we do this, we're going to say X 77, 7 minus 56, 17 minus 56. Yeah, if we send this across, we're going to get 17 minus 56. We're going to be 39 gram per mole. So in this case, therefore, element X is potassium. Because how did we know? Element X is potassium. How did we know? To identify the element X, use the periodic table. So on the periodic table, 39 is the atomic mass of potassium. So therefore, potassium becomes element. This element becomes potassium hydroxide. So we move to our next question. Our next, like this, that we have in this chart, we have potassium. Potassium is 39. So we move to our next question. Next question says name a suitable indicator for, for this titration. So the indicator for this titration is normally between a strong base and a strong acid. So we know that this is potassium hydroxide plus sulfuric acid. So the reaction, like I said, is between a strong acid and a strong base. So in this case, you can use any suitable or, or indicator. So for us in the white exam, we normally use methyl orange, or we normally use phenolphthalein indicator. So methyl orange or phenolphthalein indicator is normally used. So we use phenolphthalein indicator, or we can use methyl orange indicator. So thank you for watching my video. Hope you enjoy. See my next video again on qualitative analysis. Thank you so much. Thank you.